In general, we would like the elements of a basis to be orthogonal. As kind of an example of why, suppose you're looking at someone's location. And we'll do this in terms of vectors. The vector 1, 0 can represent 1 mile north of some starting location, and the vector 0, 1 can represent 1 mile east of some starting location. And if you can put a negative sign here for south and a negative sign here for west. Well, suppose you have a linear, this is a basis of R2, and suppose you have a vector in R2 written as a linear combination of these basis vectors. Well, we can read right off what this represents is 2 miles north, 4 miles east. Now suppose we have another basis of R2, say 1, 7, and 2, 4. Well, now our basis vectors are mixing information. This gives you information about travel north, but it also gives you information about travel east. Likewise, this second vector gives information about both north-south and east-west travel. So if we have a linear combination of these basis vectors, we can no longer simply look at this and immediately read off what it represents. We can figure out what it represents by doing the scalar multiplication and addition. Let's see, 21, 16. It represents 11 miles north, 37 miles east. But we had to actually compute this vector to figure that out. as opposed to up here where we could simply read the information off. And fundamentally, the reason that this basis was easy to work with and this basis is not so easy to work with is that these vectors are orthogonal, whereas these vectors are not orthogonal. So, when we just have two elements in the basis, well, we have a definition for what it means for two vectors to be orthogonal or not. That definition can be generalized. Say we have a whole set of vectors. This set will be called orthogonal if it is pairwise. Orthogonal. And what we mean by that is that if we take two vectors from the set and we take the dot product of these vectors, then the dot product is 0. So all the vectors in this set are orthogonal to all the other vectors in the set.